Okay, so we're going to see this mechanical system that you see on the screen right now. A simple mechanical system with a spring and a damper and a mass in here. And our objective is to find the differential equations using the bond graph model. But before that, we're going to practice the systematic way of building the bond graph model. So what I would do is I am going to put a one junction for each one of the distinct velocities, although the velocity of the wall is equal to 0. So, but still I'm going to do that. I'm going to put one velocity over here for the velocity of the mass. Yeah? And then, so that's the first step. Well, actually it's the second, because we recognize the elements first, which we have done on this picture. And so now what we need to do is to put the elements that are attached to those velocities. In here, obviously, you have the I element with the mass over here, and also you have this input here, this force in here. And then we're going to put this force, we could just say it like this, and SE with value F in here. So we have done what is attached to this. In here, this is a source of flow with velocity velocity of the wall is equal to 0. So this is like a source of flow where one of the variables has been suppressed. So this is a special source of flow because it doesn't put any velocity onto the system, but rather is the reference in here. Okay, now so this is 0. So the velocity between this and the velocity of the wall, the difference between those two, is what we are going to see that this would be like this, and then the difference, we could either draw it up here or draw it down here. It really doesn't matter. Well, we could do it down here. So this is a 1, which means the velocity of the mass minus v of the wall. And the difference okay, so we create, that's step number 4, right? Step number 5 means put the elements that are attached to those different velocity differences. So this is going to be the C element with value 1 over k, and this other one, which is going to be the R element with value v. See, and we are done. We're basically done with this. So we'll complete this. This is a source of flow because one of the signals is 0. We are going to represent it like this. See? Okay. So in here we have the bond graph model. Just is, if you put this into CAMG, the causality would be assigned for you, but in this case we're going to practice and assign it ourselves in here. Let's pick another color in here for doing that. First to the sources, which would be like this, and then in integral form for this element. When we do that, sets the flow here, then this has to be like this. This one set the flow to the 1, so this one has to be like that. If you have 2 like this, the 0 junction needs an effort in, so this is like this. Once that sets the flow for this, and these other 2 become like this. Yeah. So I would like to put some numbers into this so that we have some reference in here. 6 and 7 and let's say 8. Okay, here. What we are going to do for deriving the differential equations is actually writing the individual equations of the system and then combining those equations to create an entire system of equations that you can actually use. So I am going to say this is E sub 1, in this case is the SE1, right? F1 is this, what is F1? It's actually F sub 2. And I go on each one of them. What is E sub 2? E sub 2 is equal to E sub 1 minus E sub 3, right? So this is because of the one junction. So E sub 2 is E1, which is the input, minus E sub 3. Minus E sub 3. So we need the eraser here for a second, and that is to put the right right here, minus E sub 3. Then you have, this is E sub 2, we need F sub 2. F sub 2 is 1 over I sub 2 times P sub 2. And then you have that from this equation in here also, dP sub 2 dt is equal to E sub 2. Then I continue. I say E sub 3 is equal to what? To E5, right? Because of the causal here. What is F sub 3? F sub 3 is also F sub 2. And then I am going to go over here. See, I'm writing the individual equations. What is E sub 4? E sub 4 is equal to E sub 5. And F sub 4, you know this F sub 4 here, is equal to F sub 8. And then I go E sub 5 is equal to E sub 7 plus E sub 6. And then F sub 5, what is F sub 5 in here? Is F3 minus F sub 4. See, I'm using the zeros and ones and the individual constitutive equations. That's why we practiced that before this. So we have E5, then we have E sub 6 is equal to R sub 6 times F sub 6. What is F sub 6? Is equal to F sub 5. And what is E sub 7 is equal to 1 over C 7 times Q sub 7. What is F sub 7 is equal to F sub 5. And that dQ 7 dt is equal to F sub 7. And finally, on the last bond here, I'm just going to use the one more line. E sub 8 is equal to what? E sub 8 is equal to E sub 4. Yeah. And then F sub 8 is equal to what? SF8, which is 0. This thing is 0. And that's the end of this. These are the individual equations. That's what I'm asking you to do in your assignment, to do the individual equations. Now, you see, when you have gotten to this point, take a look at this. This one in here, plus this other one in here, these are the differential equations of the system. But when instead of living as a system of equations, of little individual equations, which combined make the entire system of equations of the entire system, you could actually use this in a computer simulation as is. In fact, CAMG uses these equations. I'll show you in a moment how that works, but if you want to have a more simplified expressions, those are called the Cauchy form. So what I would do is, in here I will start with this one. Like, I'm just gonna, maybe we'll change colors here so that we are consistent with what we're doing. This is dq7 dt is equal to f sub 7. But you see, if you look, this is f5. I substitute backwards. f5, f sub 3 minus f sub 4. I'm just going to put a separation here so we don't get confused. So this is going to be, what's f sub 3 now? Take a look at it. Go on looking for f sub 2. And f sub 4 is what? Take a look, f sub 8. Okay. What is f2? 1 over I sub 2 p sub 2 minus f8. What's f8? Is SF8. So this equation that I just got, I'm just going to use the red color to illustrate and emphasize this. This q sub 7 dt is equal to 1 over I sub 2 p sub 2 minus SF8. This equation like this is in the Cauchy form. And then I need to do it for the other one. dp sub 2, let's change colors again. And then here we say dp sub 2 dt is equal to e sub 2 right here. And e2 is e1 minus e sub 3. Yeah. And what is e1 up there? Is se1. se1. What is e sub 3? Is e5. And what is this equal to? This is se1. What is e5? e7 plus e6. Be careful with the algebra here. You need to keep the signs straight. So this is se1. se1. Just make ourselves a little bit more spacing here. Yeah, okay. There is se1 in here. This is the what is e sub 7, which in this case would be a minus 1 over c sub 7 q sub 7, and then would be a minus e sub 6, which is r sub 6 times f sub 6. So we're getting close to the simplification that we want. So dp sub 2 dt is equal to se1 minus 1 over c sub 7 q sub 7. What is r sub 6? This time f6, but f6 is f5. Yeah, times f sub 5. So because we only need to replace this, let's just do it over here. What's f5 equals to? f3 minus f sub 4. And what is f3? f2. What is f sub 4? Yeah, F8. And what's F sub 2? We have that F sub 2 is 1 over I sub 2 P sub 2. So this will be 1 over I sub 2 P sub 2. And this was F8, which is SF8. Okay, so if that's true, let's plug this in. dP sub 2 dt is equal to AC1 minus 1 over C sub 7 Q sub 7 minus R sub 6 times 1 over I sub 2 P sub 2 minus SF8. So the final equation that I will write in the Cauchy form would be dP sub 2 dt is equal to, usually the sources we put them at the end. We'll put minus 1 over C sub 7 Q sub 7 minus R sub 6 over I sub 2 P sub 2 then plus SE1 and plus R sub 6 times SF8. And this other equation, yeah, this one combined with this, see these two? These are called the Cauchy form. They are not different equations. They are just the same equations, but written in a different way. So if I can make a summary of what I just did, is I had the system, follow the procedure, put the ones first, then attach the elements that see those velocities, then put the zeros next, attach the element that see those velocities, relative velocities. Then I went into each bond and I wrote the individual constitutive relations of the elements, like this, yeah? And after that, I took the two differential equations that were generated and I did a backward substitution based on the little table in here to come up with the two equations which are the Cauchy form of the equations. So, if you run CAMG, you're going to see that the CAMG-QU equation file will produce this. I'm gonna write it perhaps here in parentheses. And the file is called CAMG-EQU.m. But this form like this one is used by the CAMG symbolic file. Okay, so that's we can see that in a demo in the future, but my point here was how we go from this bond graph to the individual constitutive equations, which in fact are an entire system of equations perfectly fine for simulation, to two expressions in the Cauchy form, which would be the simplified equations of the system.